Learner, welcome to my channel. Today we will discuss about EMR. EMR is nothing but electromagnetic radiation. So we'll discuss about that wavelength, a beam, a radiation, polychromatic and monochromatic, and some of the things to be discussed about the EMR, electromagnetic radiation. So here a beam of radiation from an electric bulb, it consists of several wavelengths. So they are productions of wavelengths they are produced from a beam of radiation from an electric bulb. It will be productions of wavelengths is very several, they different wavelengths, and it's known as a polychromatic. In case of a beam of in which all of the rays they are productions of wavelength, it will be very same, it's known as a monochromatic. If some of the students to asking, ma'am, how to they are converted to the polychromatic to converted to the monochromatic. Poly means it will be consist of more than, like monochromatic means it will be consist of only single, single or only same. Okay, like a wavelength will be same. So we need for the some filter, some beam, some beam of the filter we need to conversions of the polychromatic to the monochromatic. The next one, electromagnetic radiation is produced. So how they are produced in the electromagnetic radiation? So here the higher productions of electromagnetic radiation is produced by the events like a molecular, atomic or nuclear level. We know about that atoms, molecules as well as the nuclear. Okay, so this type of the level to be productions of electromagnetic radiation. Next, so oscillations of nuclei and electrons in electron, electrical or magnetic field, molecular bending and vibration, excitation of orbital electron, ejection of an inner orbital electron and rearrangements of other electron and nuclear breakup are some of the events which give rise to electromagnetic radiation. So here we are productions of before slide we clearly said that they are need for the molecular, atomic or nuclear level to the productions of electromagnetic radiations. So this electromagnetic radiation not only for the molecular atoms, here we also need for the some negative charges of electrons. So that type of negative charges of electron or magnetic field, so the molecular bending and vibration, excitation of orbital electron, here they are some of ejection of an inner orbital electron, and also the ejection, rearrangements, addition, we are all set of the things to be productions of to give rise to the electromagnetic radiation. So here I will clearly explain to say that electromagnetic radiation since is nothing but the hard productions of the wavelengths. Okay, so the wavelengths they are produced in the presence of electron as well as the sum of the excitation as well as the sum of the inner orbital electron and rearrangements of the electron. Since each of these events differ in terms of the energy involved, the radiation they emit with the different wavelengths. Thus, a complete spectrum of electromagnetic radiations will be produced. Okay, so the beam of light, the rays of the light, the radiation, the are productions of in different wavelengths. Okay, yes. So these type of the wavelengths to finally they are spectrum of wavelengths they are produced. Yes. So one of the earliest studied characteristics of chemical compounds was that color intensity should form the basis of most widely used set of the chemical assay. So it is here one of the characteristics. So each and every chemical compounds they having the physical as well as some characteristic is there. Some of the chemicals they are acidic in nature, basic in nature. Each and every sample of the compound they having the some characteristic is that. Okay, so The color intensity should form the basis of most widely used set of chemical assays procedure is then but natural. Okay, some of them they are present of the characteristics they are, it will be nature. Some of the chemicals they are evaporated because of that type of the chemicals they having the some set of the nature. So things they are colored because of their ability to absorb certain compounds of the electromagnetic spectrum with which they interact and consider a substance which appears green color. Okay, so here everyone know about that some type of the characteristics of the spectrum of light, they are productions of different type of the light rays, different type of color of the rays. So the colored will be absorbed that particular compound, the electromagnetic spectrum with which they interact and consider a substance which appears green in color. So if one can calculate the amount of light absorbed by this substance, one can arrive at a fair judgment about the concentration of the substance. Here, each and every places, every experiment we know about that, the type of the concentration of the substance. So how much amount of the light will be absorbed by this substance? They can be calculated. Okay, so the amount of light absorbed by the depending upon that particular substance. So that type of the substance to be helpful for the determination of the concentration of substance. Okay, so before starting this type of the law, basically colorimetry or spectrophotometry or any type of them, they need for some basic principle. Okay, each and everything they having the some set of the principle is that. Okay, so here the electromagnetic radiations also they are the initially the two different scientists to introduce the laws. So one is a Bohr-Lambert's law and another one is a Beer's law. Okay, Beer's law and one more thing is a Bohr-Lambert's law. Okay, here the absorption of light by any absorbing material is governed by two laws. That's why I will say that they depends upon the two different type of the law. So first of all, the first law is known as a Bohr-Lambert's law. That is the scientist to introduce that law. That's why the scientist name that is a Bohr-Lambert law. It states that the amount of light absorbed, kindly listen very carefully. So the amount of light absorbed is directly proportional to the thickness of a absorbing material. The first point, the amount of light absorbed is proportional to the thickness of the absorbing material and is independent intensity of the incident light. Clear? Yes. So the thickness of the absorbing material and is independent of the intensity of the incident light. So that's why. So here we are done in the Bohr-Lambert's law. Bohr-Lambert's law, what say that the state the amount of light will be absorbed is directly proportional to the thickness of the absorbing material and is independent of the intensity of the incident light. So we are understand about the thicknesses of B, it will be denoted as a B, like a absorbing of the thickness material, 50% of the incident intensity of the light passing through it. If the intensity of the radiation incident upon the such a thicknesses is assigned value is 1.0, the outcome the transmitted beam light with the value is 0.5. Totally the half of the material they are transmitted. Here same the second equal thicknesses, so always they proportional to the thickness of the absorbing material. Bohr-Lambert's law said that. So the 50% of the transmitted beam, they find the value is 0.5. The second transmitted beam will be having the value of 0.25. So here, so this structure show that in case of the sample material, it will be chosen in the 100% of the sample substance, the thicknesses material. Once the transmitted beam of they are transmitted to the through the solution, they are absorbing material is thickness is 50%. Again, they are transmitted light, they passes through the solution 25 percentage. Next one, 12.5 percentage, 6.25 percentage, and finally the 3.125 percentage. So finally, this equation show that I by I0 equal to e power minus kb, like I is nothing but that is the intensity of the transmitted light. So I naught since is nothing but the intensity of the incident light. B is nothing but that is the absorbing of the thickness, better known by the term path length. So here we have discussion about that only Bauer-Lambert's law. So here the high is since is nothing but that is the intensity of the transmitted light and the intensity of the incident light, and B is nothing but that is the absorbing thicknesses. Here the graph is also show that the graphical representations also show that the two values are like a path length and also the transmission. If your path length, they are based upon the transmission of the beam. Once the first initially they have transmission of the beam, their production is very off of them, then finally they are totally reduced in this transmission of the beam. The next one, the linear absorption coefficient of the absorbing material, the power term show the relationship by can be removed by converting to the logarithmic form. So that's why In I by I naught equal to minus kb. So here we are writing about that In I naught by I. So here the intensity of the transmitted light as well as the intensity of the incident light. Then finally the changing of the common logarithmic form, that is nothing but In, it will be converted into the logarithmic form 2.303 log chain I0 by I equal to kb. Here so that so 2.303 log chain I0 by I equal to kb. So the second law is a Beer-Lambert's law. This law said that the amount of light absorbed by a material, it is a proportional to the number of absorbing molecules. Like that is the concentration of absorbing solution. So mathematically expressed, the equations are 2.303 log chain I0 by I equal to K dash C. Absorptivity constant, the concentration of the absorbing material. So finally, the 2.303 log chain I0 by I equal to K dash C. So the Beer's law as well as a Bauer's law combines to form the one equation like a 2 log chain I0 by I ABC. So how they had this type of the equation they are produced mean, so the first equations of the kb and as well as the k dash c, k dash, it's finally they converted to merge to form a single constant like a, and also the 2.303 they cancel, they log chain I0 by I equal to ABC. So finally what is the conclusions of the Beer-Lambert's law? This combined law the state that the amount of light absorbed material is directly proportional to the concentration of absorbing substance and the thicknesses of the absorbing material. So finally, I0 by I is known as the absorbance. The reverse form of I by I0 is known as the transmittance. So finally, the Beer-Lambert's law to conclude this type of the equation. Thank you all.